Thank you very much. Thank you, Tal, for organizing everything and topic for the amazing talk and the lectures. And also, I'd like to thank Professor Rad for the interesting theory. And before I start, I would like to say also many thanks to Dr. Neta Rabin and Dr. Ilah Chalutz Bengal that were my mentors in this research and taught me how to make academic research, how to write a paper, and actually everything I know, I must thank them. So my topic is reducing AI bias in online recruitment systems by identifying gender gaps in LinkedIn profiles, utilizing NLP and Kernel Two sample tests. So first of all, I want to introduce the topic and myself. I made my first degree here in Tel Aviv University as an industrial engineer. I work in startup company and Microsoft, HP, in different kind of positions. I was also a release manager and also account manager. But eventually I understood that I really love data and I want to focus more in data and machine learning. And this is what brought me here to do my second degree in industrial engineering here in the data analytics program. I want to say that it's very enriching program, and I really strongly recommend it for everyone interested in this field. And so in the beginning of the research, we made a partnership with a company, Talengia Inc. It's an Israeli company that provides AI online recruitment, LinkedIn-based software, which finds the rank qualified and diverse candidates for recruiters' open positions. For example, if a recruiter is looking for potential candidate, you can use this software. It takes the millions of profiles from LinkedIn and can really identify the right people for the position and rank them in a way that will be easy for the recruiter to find what he's looking for. Talenia motivates a lot around diversity. One of the main objectives is to try to help ethical groups and females to get higher ranks than the original LinkedIn itself. So the first thing we wanted to do was to find if the algorithms that Talenia uses is discriminating or not, because this is a very important start point. So we made some statistical tests and we saw that it's not discriminating. It's the same proportion that you find in the population will be the same in the higher ranks and even better. So why AI bias in online candidate recruitment system is so important? Because today social network is the major recruitment tool for companies worldwide, and most technological high-tech positions today are still held by white men. In the high-tech technology, still also 80% are still male in the technological positions. And also when you use AI, computer systems are usually mimic the same patterns they find in the training data. So if we have a bias in the training data, the same bias will be also in the results. And this is something that is very important that AI systems will take and make some corrective actions, not to take a social situation that has been make it worse, but we want to make things better. So Talenia took 10 million candidates profiles, and they found that an average female writes 34% less text than men. So this is also something that okay.
Your scene is not.
You can, okay, when I change, sorry. Okay, so can I change move from here or no? Okay, thank you. So some related.
You want from this slide?
Yes, it's okay. I know I'm here before. I was here. Okay.
And, this issue.
Can you see it now? Yes. Okay. So today's work for diversity drives the need to reduce AI bias. So some few examples from the real world. So NASDAQ, they ask a company that is written in the NASDAQ to have at least one ethnic and one female in the board. This is why companies also are interested in diversity. Also, there is some examples here from Amazon. Amazon in 2018, they produced a system for online automatic recruitment, and the system found to be discriminative against female also because that historical data, they found that most of the software developers are men, so the system understood that being a white man is good for software development. So after that, Amazon took off the system. Also, this female up there is a researcher from Google that was that had a research that some NLP transformers like BERT are still discriminative, and this is why she was also pushed back from Google because sorry, she wanted to push back the her paper, so Google fired her, and it was a huge story. So some related research regarding bias and its influence on automatic systems. So there is a few work that were done in this topic. Regarding LinkedIn, not so much. Mostly some Israeli professor. They found that female tend to signal more emotion in their pictures than men. But there is not a really deep research on textual differences between men and women. So when we find the gap that we wanted to focus in the research, we found the three gaps. One is the textual self-presentation gap, that there is no one that really got into it deeply to see female write the same as men in their LinkedIn profiles. When we talk about similarity, we talk about the distribution of the text, of the skills that the female writing the text and of the executive summaries, etc. Also, we didn't see a really deep content-based that talks about the differences that are differ across socio-demographic and organizational features. For example, the profession infects the way that men and women write about themselves, their location. For example, in New York City or in Europe, we found in many cases that female write more about themselves than in other locations. Also, the seniority level also is a feature that is very important when we're talking about the way that a person presents himself. And the third thing is the method base. There is a lot of talk about the bias in the data, but the way that to measure this bias wasn't so, it's not always so clear, especially when we talk about high dimensionality and text to find bias between text. So we find that we took something from the world of multidimensional statistical tests. It's called Kernel Two sample test, and we use it on the NLP text to find if there is a bias between men and women in the way they write the text. So our data was taken from Talenia. We had around 14,000 candidates, men and women, from LinkedIn profiles. We had a full profile of them, and also we had something that Talenia has in addition to this data. They had artificial skills. They tried by their AI algorithm to realize if some candidate didn't mention a skill that he has. this is a black box for us, but we understand the logic. They're taking it from the text, from different sites that the user is presenting himself, or from users that are similar to the same user and they have a different skills that this specific candidate didn't mention, so they added to the profile.
So you have sets of this black box, and then on that black box you perform all those things?
No, actually, we did all the experience on the data without the black box. We only have some output from the black box, but most of the research was on the pure LinkedIn profiles. So these are features from LinkedIn, as you see, the location, the education, the average tenure, the skills, the executive summary, and so on. And for example, if we can see a sample of the data, we see that this candidate, she is working in content, and she also write it in her executive summary. She also repeated in their skills and the title. And when repeating the same skill in a few places in the profile, it actually, the AI algorithm, give it more weight. So this is why it's important that candidates will also repeat their skills and the executive summary to mention the very important skills they have. And unfortunately, we see that females not always tend to do it as much as men. This is the dataset description we have. So you see, we have around 20% female. It's pretty much the same as in the a priori, and categorized by continent, country, subregions in the US, seniority level, and position type. As we wanted to take a look on the correlation method, also we talked some lectures before that we can see correlation between features. We didn't find a clear correlation between the gender and any other feature. So as you can see, there's not like that the female have less education or they have less experience or anything, but in the text we can see after that a clear differences. So the methods we used in this research, I took the universal sentence encoder. This is a transformer that you can easily train the data for full sentences and apply it as a vector of numbers that describes the sentence. The reason I picked this